Alright, so what you're going to learn in this lecture 2. So lecture 2 of 5, what you're going to learn is the subtopic. This is a new subtopic, binomial distribution. Okay, so at the end of this lecture, you should be able to identify the binomial distribution. Listen, okay, X is binomially distributed with parameters n and p. Parameters, okay. The second one, determine the probability of an event. Okay, for this part, we're going to learn this one tomorrow, I guess. Okay, P is less than 0.5. Okay, P is less than 0.5. Okay. Alright, let's go to the first part first. Just an introduction to binomial. Okay. Alright, so subtopic 6.2, binomial distributions. We're going to learn how to identify the binomial distribution. Okay. So what is the characteristics of binomial distribution? So binomial distribution is also discrete random variable. Okay, means you still can count it. Okay, masih lagi boleh dikira. What are the characteristics? Let's take a look. Okay, so this is most common. You baca, you figure out, is there two possible outcomes? Binomial. Okay, paling senang nak cam. Ada two possible outcomes. Okay, success or failure. Ada defect dengan not defect. Okay, success and failure. Two possible outcomes. Okay, ada fixed trials and trials. Okay, and fixed trials. Okay, and fixed trials. Okay. So if it has two possible outcomes, means we're going to have this distribution, the probability of success P. Let's denote P. Okay, probability of success, and the probability of failure, which is Q, and both probability is constant for each trials. Macam you baling dice. Okay, you baling dice 1/2. Okay, baling lagi 1/2. Itu baling apa tu? Dadu dua surface dia. Okay, dadu ada berapa surface? 6. Okay, so once you toss 1/6, baling lagi 1/6. Okay, it's constant for each trials. Okay, everybody must know this. Semua orang kena tahu yang ini. Okay, so this is probability of success. Okay, nak cari dia 1 minus Q. Okay, sama juga kalau you ada probability of failure, you nak cari 1 minus P. 1 minus je. Okay, 1 minus. Okay, it's going to complement each other. Okay, and the trials are independent of each other. Means you baling dice tadi, you nak dapat nombor 2. It doesn't depends on you baling, you dapat number 6. No. Okay, so that what it means by the word independent. Okay, tak bergantung di antara trials tu. Okay, alright, now let's determine whether the following situation can be modeled by a binomial distributions. Okay, so what we're going to do, the number of heads obtained when unbiased coin is tossed 10 times. Okay, let's check one by one. Okay, kita check dia punya characteristics tu setiap satu. Okay, ada two possible outcomes. Yes, of course, you toss coins, you akan dapat apa? Heads or tail, kan? Akan dapat either one. Okay, heads and tail lah. Okay, ada berapa trials tadi? 10 trials. Okay, 10 trials. Okay, 10 trials. Kalau you baling heads, what do you expect the probability? You nak dapat heads 1/2. Okay, kalau you baling, mungkin nak dapat tail pun juga 1/2. Okay, ini untuk dapat tail, the probability to get tail. This one, the probability to get heads. Okay, and these two trials are constant for each other. You baling tak bergantung kepada you baling sekali lagi tu dapat heads dulu, lepas tu mesti dapat tail. Tak. Okay, no, right? And these trials, these independent of each other lah. Okay, they're independent. So what you can say that this distribution is binomial distribution. Okay, kalau kita check all the characteristics, this is binomial distributions. Okay, so ini adalah binomial distributions. Okay.